اوكي كمان دقيقة بنكون عارفين. يعني نحن نتحدث عن مجزرة صعبة جدا وقاسية حتى من شهادة صديقي. الآن معي أنا اثنين كانوا موجودين في المكان، خالي محمد، خالي فقد أخته، فقد والدته بالإضافة لأبو عبد الله بالإضافة لبسملة، ستك يا خالي موجودة قد تكون بتر بالإضافة لأبو عبد الله. الآن احكي لنا شو اللي صار معكم؟ أول شيء شو اللي خلاكم تختاروا المعمدان علشان تروحوا عليه؟ أول شيء قديش كان لكم في المستشفى ساعتها في السفر؟
جلست حوالي ربع ساعة لغاية مجال خط الحي.
وين انت كنت موجود وين كانت امك المرحومة رحمة الله عليها وجودك الاستشفاء؟
صار القصص كان ورانا تقريبا انا ضابط في ستة طالب عطلت مع النار نشر هي
طيب خالي الان اصوات الانفجارات هائله. محمود انت كنت كيف خالي اول واحد يمكن وصل للمكان، وصف لي شو اللي شفته اول ما دخلت المكان المستشفى؟
كنت جانب
يعني استغربنا كمية الانفجار من عدة ايام لم يقع، يعني انفجار ضخم ونيران وبور يعني احمر لا ناطر. توقعنا بما انه نعرف انه موجودين في المستشفى، توقعنا انه في المستشفى، لكن كنا بعيد او انه لا يجوز استهداف المستشفى بشكل خاص. يعني في الواقع يعني مبنى او عمارة او برج طرق تحذيري قبل استهداف مجموعة كبيرة، يعني الناس موجودة في المستشفى، مكان يعني آمن باعتقاد انه الناس كلها نزحت في مكان قتل إلى مكان أأمن من القتل اللي موجود كان فيه. يعني مجرد ما سمعنا الانفجار الهائل وتوقعنا انه موجود في المكان هذا، يعني جرينا مشهد لضرب لم اتخيل. يعني من باب المستشفى لمكان الانفجار الجثث واشلاء، يعني ارجل واقدام وكل مكان. يعني دخلت المستشفى يعني مشهد لا اجداد ولا والدي لم يراه من قبل. شو عملت والدتك؟ انهيار عصبي، يعني ربنا يتولانا برحمته ويلطف فيه. كانت بعد سنين عظم الله هذه عظم الله كانت مقابلة. على كل الأحوال يعني الأوضاع جد صعبة بشكل عام في المستشفى، لكن نعم صحيح. أنا بعتقد صحيح، أنا بعتقد في البداية فقط والد زوجتي كان الأولاد يوم إلى رمضان الأربعة أسقط عليهم تفجيرات تكفي لنسف كل الأزمة. في اليوم الثالث فقط أخرجنا الحج من تحت الأمطار. اليوم بنت أختي بالإضافة إلى أولادها بالإضافة إلى إصابات كثير، لكن أنا أستطيع أن أؤكد أنه لا وقت للحزن الآن، بمعنى يجب أن نأخذ الصواب. هذا وقت الرسالة، هذا وقت أن نقول للعالم أن هناك ناس لا يسبقون بالموت بالصمت، بمعنى أن هذا كرم من الله عز وجل أننا أصبحنا لسان لا لسان له. وبالتالي أعتقد أن هناك صعوبات كبيرة جدا هنا في المستشفى. أحيانا نتكلم حتى على مشاعرنا، نحن كمان عندنا أولاد وعندنا أهل وعندنا أولاد صغار وعندي أحفاد، ومع كل ضربة حتى وإحنا على الهواء بقول الآن سأرى حبيبي فوق أجداد، لكن في النهاية هذه حرب وهذه قدر الناس. الآن هناك فوازير بانتظار أن يتم إجراء العمليات لهم. عمليا فقط يوجد أعتقد 51 غرفة عمليات موجودة، ال 51 غرفة عمليات باتت مشغولة. للأسف بأنه في المكان خلفي هذا اللي هو المكان، نعم المكان الكرميد هذا ترى الآن، نعم هذا فقط دقيقة. نعم هذا المكان الكرميد أنت ترى حوله أناس. الآن هناك عشرات الجثث تحت الكرميد. الناس بتيجي وبتكشف عن وجود الضحايا، بعضها أشلاء ووضعها مشوه فقط للتعرف، لأنه هذول مجهولين الهوية الآن. استطاعوا أن يتعرفوا على العديد من الشخصيات بهذا الشكل، لكن في النهاية لن يتمكنوا من التعرف على الباقي لأنه عبارة عن أشلاء. وأعتقد أنه سيتم دفنهم في الغد في مقبرة مثل المقبرة التي بمعنى قبر جماعي، حتى بدون أسماء بدون شاهد للقبر، وإنما فقط مجموعة من الفلسطينيين التي قتلت دفعة واحدة في مكان في الأصل ينتمي لكنيسة الروم الأرثوذكس، وفي المستشفى التابعة للكنيسة، والتي اعتقدوا خطأ أنها آمنة. شكرا. على الخير. ايوه خالد وصل معكم. Basically what's going on at the moment is bombing everywhere. And that's everyone living areas at the hospital here. And what happened in the hospital is a disaster because doctors are not able to use because they do surgery to these people in Florida. They don't have the tools to do their jobs. And we work international because they want services to stop the health
الصوت والصورة كويس. الو التليفون شغال لدي شغال المسطرة.
جونا
Mongolia, Vietnam, Turkmenistan, UN, Ethiopia, Kazakhstan, Chinese President, Russia, Indonesia, Uzbekistan.
Me? All together and also Ethiopia. No, it's a group photo. Yeah, only group photo.
Nigeria, Pakistan, Thailand, Hungary, Kenya, Sri Lanka, Egypt, Cambodia, Mozambique, United Arab Emirates. Okay?
What do you want to?
Only checking before we want to walk crochet or just but what's the point?
I'm sorting. Huh?
方三，我带他去一下洗手间。上那边去。刚才那儿有。
Right?
不好意思，先生，我请问一下，就是一会儿进来会有握手，还是说直接就拍照？
直接就进来。
直接进来。
Yes, right.
When you want to shoot a walking, let me. Because when they're walking, where are they going?
Oh, over here. Over here. Starting from here, outline. Done. Then picture.
这里它有分吗？你看看这里面有没有？没有，那我就不知道。
Because we don't have a choice. Like this lens is big. This camera lens is big, and so it will block.
那记者我哪能知道？你在一楼找了吗？没有。你在一楼找了吗？B1 B2，他 B1 B2没有，那就没有其他人，可能这里面没有人。
就可以差不多。对，所以你说那个。所以现在是他的选择为主。现在是19。
哪有外挂？真有。
I'm gonna take his also.
我们早早的把这个
又开机要试。我这边开机，跟经常说我这边我开机了。
这哥们是谁啊？让他进去，不要走外门。
我现在插着新闻呢。照那画儿，
不赶紧去一下，他有的是找你。
然后你去问一下数码实践厂家，我这个插2电为什么还在提示我接入外部电源？对，它还在提示我接入外部电源。
干了干嘛？找到了。进去了吗？
你们俩人能分一个人过来吗？要分一个人。
有女的可以亲了，还是比3呢？
你联系孙帅，或者往这里。
进来了。哦，
哎，在哪？
在这个后面。
是吧？
这个智利只有他一个人是吗？今天总共就他一个人。那你一会儿把那个带上，那你这儿带。
关了吧？对。这个不行，这个。但是我觉得您这个机子保留靠谱。以后一直开着机了，你要换就赶紧换。因为我这住这一块电池又正式活动了，没电了。哦，
对，我也在打电话。
当时
这个
不用我这包了。
Which country？ 希望是带对，要不然你看这个。 你的定位是在这吗？
我知道。
今天黄金文不在这儿吗？
这开吗？
黄金文在这儿吗？
就开线不用了，就线不用了，机器。
You're an independent media? Oh, it's on the 24.
哦，我换27那个机位，我换27EF 了。
No?
当然我现在摄像机没电，我没法给你看镜头。
Wait. That's, oh yes. Maybe you missed someone. Just a little. I think after we finish, they will take us to the bus, right? Yeah, I guess. Maybe I can share my footage with you, with the trick. Why not?
戴耳机。
肓骨泉就是它把还特宽，可是吧，咱们很小，别跟车里我觉得还挺重要的。对，我看我本来想从就是中间那人从奥的出来的，那行那就看。从奥的就肓骨泉了。就2层。哦。因为前面当时机器太高了，就进来肯定是他们的机器，我要往里对对，是我的。对，那是我的。
我现在。你要干什么？我才开2分钟的机。2分钟？这不是没电了吗？
现在赶紧试吧。
他说没电了，他说就带了一会儿就没电。
那你赶紧试吧。
是不是啊？我给你开试。
我也去一趟啊。
对对对。
And then you're going to stay there? Just trying and get back. Yes. Because these people are trying to take your place. You know? As soon as you move it. Leave your bag over here. Okay. Yes. Do that.
Get out here. You boy, I need to out here. Go up into this.
No, she'll come back. She's just trying.
Trying to get
Taste.
location.
Try.
Vea, oye.
Después que teníamos era la sola oficina, la entrada al plenario, podemos solo entrar a uno. Pusieron muchos problemas a la dictación. Pero son unos planes que estamos viendo más importantes. Creo que lo más importante es empezar.
它那个实际上马超不在焰火厅里。
我来找你领标，比预想的好一点哈，没有比昨天好点。
昨天这问题就是临时当合影架，然后那个一般
那个数号的。
不让。
那个当然到了，我没法从后往上上，毕竟是前对边。
我跟你讲，最大的问题就是那个地方就不应该是合影架的，那是他妈是个动线，只有领导人全进去了以后才能推过来。你像这个今天就没问题，直接有这个地方肯定不会出起冲突，然后人数也控制了。昨天就他妈这个事情，8点钟开协会，开到晚上1点多钟，讲这个事，打了这也没多大个事，我也不在的吧。这老师有说很把简单的事情复杂，是吧？对，你先天就设计的不好。来，等等。这一下子就是河北。这一下子也是东大厅，那里河北厅。
我拿走3，我拿走4。
这些人都不能进，这跟他下午搞了一次大秀，到时候就是要给这个
还是在听理过程。对。然后我们开幕式的人最迟什么时候下？最后一个致辞我们下去行吗？可以吧？来得及，不用再等。对对，行。然后他们那个开幕式道别有没有在？
这是北京厅，
北京厅道别。哦，好。
就是新华的证上面标还没发，新华
对他们还没来，
其他账号都已经发完了。
没有，他刚才李征只是拿了摄像，还有新媒体的那些编辑
媒体都已经在里面。
对，就是你要考虑这个话呢，其实
他没有，就会让他来找你，你找他们。
行。
风险自担啊，风险自担，我们就。现在外宾都没到齐，9点55能准时开始。 都不能动。走的时候一定要卡住哈，记得一个都不能出来。
就他们没走进去之前。
啊，当然。15个团，15个团还有11个团。
人下不去。
等那个投完影以后，所有的外装技术我就把它带到下面去，地下大厅，让那个这个箱体上的接口东门外，就这个东门，对呀，东门但是谁管咱们呢？只要带到东门就可以，然后这个基本上把咱灭了下去。
而且本身在这个方案中，它要第一波机上车，回来才这个。
还是在东门内，东门内。太多了，这样大家都看不懂。说什么江西一会儿还要去中南海，他那个钓人钓疯了，有雪鹰说就在下面，到时候我们会下面，然后当兵跟着，等那个他们说完那个给他们员把带往上开，期待一下大巴情况。然后这个没问题，你那个你行，只有雪鹰才能找到这个点，跟雪鹰说好，跟雪鹰说好。
专业。完了以后也是到楼下的，都跟着我们一起，都跟着我们一起。早上进去以后，我们把这个外围跟着你跑。Not now, not now.
这
那咱们完了以后，多花点。
它是放重庆放假的。
我跟你讲，我那天那天11天，我11天我去那个，不是，但是放那个这标准的。
So everyone, 5 minutes.
just like this.
转过身，转过身，转过身，哎，行，这边快开始了。
This is fine, right? Yeah?
Just yep.
What happened?
Why?
对，这边快开始。
فقد الشاهد
Thank you. The head of the flash is coming here. Sure. You don't want.
Yeah. Push it to the roof.
Ladies and gentlemen, please double check. Your mobile phone is in silent mode. Check your mobile phone. Yeah. Thank you.
Can you check the accounts? Me. Oh, this is it.
大家好。
大家好，大家好。How nice to have you here.
Thank you. I'm delighted to be here.
Yeah, we're very excited to have Jensen to be with us for this, the most important exhibition that we have for the year. And first of all, let's say hello to our guests, right? Good morning.
Good morning.
Thank you all for coming. For those of you who have come here before, thank you for your continuous support and interest. And for those of you who come here the first time, hopefully you will enjoy what you will be seeing today. Today we have many important guests, but the most important guest, you know what? Do I have to introduce him? Do you guys know who he is?
I would still love an introduction.
Jensen Huang, the co-founder and CEO of NVIDIA, who was recently known to be the most popular CEO in the States. Congratulations.
Thank you.
Thank you. And, this is the first time for him to join our exhibitions. First time for him to see our EVs, and first time for him to sit in our new EV. What do you think about this EV?
It's a beautiful car. This is an ideal car for a young couple like Young and me. Isn't that beautiful? The ideal young couple car.
Yes, this is built for young couples. And we call it Model B, which stands for Beauty and Beast.
Okay.
And it runs like a beast.
Which one are you and which one am I?
It's more of both. Okay, so we also show you about our exhibition regarding the servers.
Yeah, incredible technology.
Yeah, servers which you're the expert in. And also we have shown you something about our semiconductors, right?
Yeah.
What do you think about it? What do you think of it?
Well, today, before all of you get to enjoy it, I've already enjoyed the exhibits. The spectrum of technologies that Foxconn has is absolutely incredible. And I had the benefit of seeing some amazing technology, fully integrated cars and integrated platforms, from thermal technology to electric delivery technology to semiconductor technology and software technology that integrates these amazing systems. As you all know, we're at the beginning of a new computing revolution. The way that we do computing has largely been unchanged for the last 60 years, since the invention of the IBM System 360.
Exactly.
And now we are starting a new revolution in computing with at its foundation called accelerated computing that we had the benefit of pioneering. And it enabled a brand new way of doing software called generative AI. Yeah. And all of that can't be possible without its foundation of semiconductor technology. And so I'm delighted to be here to see all the advancements.
Jensen was regarded as the godfather of AI. Definitely he will talk to you more about the AI, okay? But I think, I remember the very first meeting after the Chinese New Year, I asked all my top managers into a meeting. In that meeting, I told everybody about how important it is to understand generative AI. It will have big, very huge impact in our daily work. Not just the devices, not just the servers, but our daily work. And I was talking to Jensen about, I remember, when we first had a CPU and we put a lot of CPUs together, we call it number crunching machine. And then when I visit your headquarters, I saw a lot of triangles. And that reminds me of, oh, the GPU was a triangle crunching machine. But today, with Gen AI, the GPU turns itself from triangle processing machines into a token processing machine. It processes a lot of tokens.
Neurotokens.
Neurotokens, right. And day before yesterday, we had a pre-meeting. And I, from Jensen, I heard from Jensen in person about his view of what the future of AI is. The concept of AI factories. I read the articles in your GTC conference. By reading it, it's really, I didn't really get it. But with the short meeting 2 days ago, oh, I think I got it. But I think it's beneficial for all of us to hear more about the AI factories from Jensen in person. Is that okay?
Yes, of course. Let me show you a schematic of a cartoon. This is why Young and I.
Yeah, let's move the car so that people can see. Yeah.
So this is the schematic of what Young and I are building, and it's a I drew it myself, so you could please excuse the artistry. But we're at the beginning of a brand new way of doing software, using computers to write software that no humans can, but these computers have to be extraordinary computers. There are 3 fundamental ingredients of the generative AI revolution. The first, of course, is the algorithm, the neural network algorithm that allows the computer to learn from its experience, which is data. The second is you have to have abundance of data. Data is the digital version of life experience. This is no different than us learning from our life experience. Digital data allows the AI to learn. But in order to learn, you need a powerful computer. This powerful computer is, of course, founded on advanced semiconductors, but the architecture of this computer is completely different than the type of computer we used to use. Yeah. And this AI factory, if you will, takes raw material in, which is called data, process it in a factory, an AI supercomputer, running the artificial intelligence neural network model, and it produces intelligence. This is a factory that takes data input and produce intelligence as an output.
Exactly.
It's a factory. It's an AI factory. And in the future, every industry, every company will have AI factories. In this particular example we're showing you today, what Young and Foxconn and NVIDIA are building is an entire end-to-end system where, on the one hand, you're building this advanced EV car, this beautiful Model B, with a AI brain inside that allows it to interact with the drivers and interact with the passengers, as well as autonomously drive. Complemented by an AI factory, the AI factory would develop the software for this car. Yep. This car would, of course, go through life experience and collect more data. The data would go to the AI factory. The AI factory would improve the software and update the entire AI fleet. This entire end-to-end system, on the one hand, AI factory, on the other hand, AI AV fleet, is what NVIDIA and Foxconn are building.
Yes, this great concept of AI factories, it just so happened that Foxconn is trying to convert itself from a manufacturing service company to a platform solution company. the platforms that we were targeting are the 3 platforms. Number 1 was the smart city platform. Number 2 is smart manufacturing platforms. The number 3 is smart EV platforms. Now I know what can power and what can make this smart platform happen.
Just as the car has an AI brain, the factory also has an AI brain, and that AI brain is the NVIDIA DGX SuperPod. Let me show it to you.
Yeah.
It's good to see what it looks like. It starts with amazing chips. This is the Grace Hopper Super Chip, the world's first of its kind. It's connected into 32 unit pod with this very high-speed interconnect called NVLink. 32 of them are connected together using InfiniBand, and this represents one SuperPod, and an AI factory would have many of these. This is a factory of the future. There will be smart factories that build cars. There will be smart factories that build AIs.
Yes.
And these 2 factories will be complements of each other. Both of them continuously running, both of them continuously creating value.
Right. And the most importantly is we are building these factories together.
Yes, we're building these factories together.
And Foxconn is building all this together.
And so I'm delighted to be here to see all my friends that works with us on these 2 initiatives, both NVIDIA technology and Foxconn technology on the AI factory, NVIDIA technology and Foxconn technology in the EV and AV cars.
Yes.
I'm delighted to be here to celebrate it with all my friends and to announce the expansion of our partnership into these 2 areas.
Yes. That's wonderful. That's wonderful. And we will be, together we will be, helping out the whole industry to move much faster into this, the AI factory, the new era of the new AI.
And the schematic that we showed, our cartoon,
Yep.
can be replicated to every industry. It can be an AI factory in AV, an AI factory robotics,
Right.
AI factory smart city,
smart city,
AI factory smart manufacturing, so on and so forth.
Right.
Yeah, really
right.
scalable approach.
Yeah, very exciting, very exciting. But you know what? With all these ideas with AI, you need to have some hardware to power it. Without the semiconductors, the AI probably can do only so much. So
the foundation of intelligence is the brain, of course, but the foundation of artificial intelligence is semiconductors.
Yes, and in terms of semiconductors, we know NVIDIA was the highest market capitalization company in the semiconductor industry.
Thank you.
Can you tell us a little bit more about NVIDIA in semiconductors? What are you doing?
Well, our work in semiconductors is pretty broad-based. Most people know us because we've been a graphics chip maker for so long. They recognize us as a GPU company. But today, NVIDIA really is a data center scale computing company. Most of the computers of the future that are interesting are going to be data center scaled. You want to be data center scale because the density could be high, the energy efficiency could be very, very high, and therefore we could be as carbon neutral as possible for the Earth, much more sustainable. So the concentration of data centers is important. In order for us to create these amazing data centers and do computing at the scale that I've just shown you, you need, of course, GPUs, CPUs, networking processors, networking switches, silicon photonics, all kinds of different technology, software technology to operate this AI data center. NVIDIA's focus is really to advance these incredible data centers so that we could scale it out for every industry and every single company. And so we have giant semiconductor design teams, chip design teams, that are basically designing chips that fit into this entire data center. And so our work in semiconductors is broad and deep.
The semiconductor they're creating, now is about 700 watts a piece. It's going towards like 1,200. It's, you know, it's going bigger and bigger. And in terms of data center, the rack, the power to the rack on the average currently is about 25 kilowatt hour. And
25 kilowatts, right?
yeah, yeah,
25,000 watts.
And
right.
it's going to 100, 140.
Now, just to think, a hyperscale, traditional hyperscale and data center scale racks are 10 kilowatts. 10.
10, yes.
And now we're moving to 25, as you mentioned,
Yeah.
and to 100 kilowatts.
Right.
10 times the power. But what's amazing is the amount of computing density has increased by thousands of times.
Yes.
And so therefore, the energy efficiency of computing is going to increase tremendously. This is one of the most important things we have to do in order to have sustainable computing in the future. We have to accelerate every workload that we can. We have to densify computing whenever we can, and when we do that, we could apply the latest state-of-the-art technologies in power delivery, in thermal cooling, liquid
Yes.
cooling, and
Yeah.
other technologies to increase the energy efficiency of data centers.
Mm-hmm. You know what? This is a big change. And this is also a myth and also a disruption to the data center industries. You know, without the advent of semiconductors, this probably will not be able to happen.
That's right.
Okay. And talking about semiconductors, we have a semiconductor guru here, and who is your friend. Okay. So let's welcome Dr. Sang-Yi Zhang to be on the stage and say hello to our dear
Let's
friend.
welcome Semiconductor Chief Strategy Officer, Dr.
Good to see you
Zhang.
again. So nice to see you.
Congratulations.
Oh, congratulations to you. We're old friends from a long time ago.
Right.
We worked together a very long time.
Right. It's so great to have you here.
Thank you.
And we would like to see you more, and to share with all our friends about the future of AI.
Yes.
Okay.
Thank you.
Thank you. Thank you.
Thank
and
you
we'll
for
leave
coming.
the stage to you.
Thank
Yeah.
Okay.
Okay.
See you at
Thank
the night market.
At the night market, if you run into him, it's free.
Morning, everyone. It's my great pleasure to be here this morning to share with you the semiconductor strategy for Foxconn. It's a year ago today, I was here in the audience as a visitor, and I was so impressed and decided to join Foxconn 1 month later. So after I share with you our semiconductor strategy, if any one of you agree and would like to work with us, please let me know. My presentation will have two parts. The first part will be I'd like to propose a new business model. We call it system foundry. This is more like a long-term strategy. Because electric vehicle is such an important focus for Hong Hai. I would also like to share with you the semiconductor deployment plan on electric vehicles specifically. So let's go to the first topic. Okay. We see the semiconductor, that is electronics industry, has been, like Jensen just said, it was powered by semiconductor technology. And it gives the electronics industry such a booming half-century. But now we see that environment is changing. It's a big issue that we know this called Moore's law. The scaling of semiconductor integrated circuit. And every 2 years, we make the transistor smaller, so the speed becomes faster, the power becomes lower, the power density becomes better, and most importantly, the cost becomes lower. That enables this, we have many different products that performance got improved, also developed into more functionality, more applications. But now Moore's law is reaching its physical limit. If we talk about 2 nanometer technology, what 2 nanometer mean? That means 4 atomic layers. But of course, when we talk about 2 nanometer today, it's nothing on the chip. Really, it's 2 nanometer. I think before 40 nanometer, you read it, if you 40 nanometer means the smallest dimension is 40 nanometer. But today, the 2 nanometer is just a marketing term. But still, that is a good example that we are reaching its physical limit. Then it's going to make a big impact. What are we going to do? I think most importantly, I hope we can come up with some new technology platform to replace this silicon IC. But we're still waiting for that to happen. Before that happens, let's look at for possible solutions. If these silicon chips begin to reach its physical limit, let's look at the entire system to see if any place we can make improvement. We found that every 2 years the silicon technology was improved, but the package technology and PC board, performance-wise, they didn't improve too much. They did a very, very good job in reducing the cost, but not performance. For example, when the silicon technology go down to nanometer range, the metal line on PC board is still the metal pitch is 100 micron range. And that gives us and it becomes the bottleneck in many cases for the system performance. Especially like Jensen just said about this GPU and AI, actually the bottleneck was package. And I'd like to share with you later. So this is from the technology point of view, we see some opportunity to improve. Let's look at the demand and the application side. Today we have the most advanced silicon technology with a 3-4 nanometer, but it's very expensive to use. The wafer cost is above $10,000 a wafer. The photo mask costs close to $20 million a set of photo masks. And more importantly, the design cost to design a product in 4 nanometers are $2 billion. If you spend $2 billion to design this product, you have to sell at least $10 billion to cover your cost. And how many products you can sell for such a large volume is limited. For the same time, we see in the past, the semiconductor technology was driven by mainframe computer, desktop computer, personal computer, cell phone to smartphone. And all those pretty much is a single product. They have a very large volume. But now we see the application going forward is pretty dominated by what we call IoT or AIoT. This is a very, very scattered market. We have a personal use, we have a smart home, smart city, smart car, and a smart industry. And in each category, there are hundreds of products. So all these together, there are 1,000 products. So it's difficult to use a 3-4 nanometer technology for such a scattered market. So we need some solution in that too. So we have, now we bring up the environment is changing. One is the technology side and one is the application side. The business model we propose, we call it System Foundry, is set to solve these two issues. So let's first go to the performance side. I just said that the package and the print circuit PC board become a bottleneck. In 2010, when I worked in my previous company, we did a simulation because at that time, our biggest customer is in graphics. And we found that doing simulation, graphics on chip work very, very fast. However, you have to, because the parallel processor, you have to exchange data between GPU and DRAMs. And we did a simulation, just going back and forth to send the data from GPU to DRAM, take away 40% of the speed and 60% of the power. So that's become a big, big bottleneck. As you can see, we highlight in the blue square, this is on the PC, personal computer PC board. That is the graphics module. In the middle is the GPU, and the side is 8 DRAMs. And they locate so far apart. Why they are so far apart? Because the metal line, the metal pitch is 100 micron, and you fan out 1,000 metal lines, so they have to be far apart. And as a result, you have a very large loading. It slows down your signal process, propagation, also it's aware your power. And we thought about it on the silicon, then how we solve this issue. We realized on silicon wafer, I can do 100 nanometer easily, which is 1,000 times better. And this interconnect is the metal line is a 2-dimension. So if you look at the metal density, is 1 million times better. If I use a silicon to replace this substrate or PC board, we can put this GPU and the DRAM almost like next to each other. We can recover almost all of this 40% speed loss and 60% of power. And we call this technology advanced package. With the advanced package platforms, most importantly is that you can make many chips connect with the advanced package. They function very much like a single chip. This is very important. Let's go to next. Because of this, because we can use advanced package technology, we can make the performance very much like a single chip. Let's go to next. That also gives us a solution for the very scattered market demand. This is just a schematic showing we put a GPU and we even stack DRAMs on top of each other. With these 8 DRAMs, we put them into 2 stacks with 4 each. And we can put them very close to each other. So let's go to next. So this is use an advanced package platform. We can improve the performance. Then go to the other part. We say the IoT market is very, very scattered, so it's very difficult to push this product. However, there is something in common. All the IoT products, their structure is very similar. They all have some kind of central processing unit, and they have a lot of sensors. And sensors take the analog signal, so you convert to digital, you need A to D, D to A, and then your power management, your memory, and you have some communication tools like Wi-Fi and Bluetooth. But all these 1,000 products, their structure are very similar, but the requirements for each component are different. For example, for the central processing unit, for electric car, the auto driving function, you need very, very high performance. But for some personal wearing device, this process unit can be very simple. So what if we make for each component, we take apart this system into pieces and use a kind of Lego approach, 搭积木的这个方式啊。So for each subsystem, we can offer different functionality chips. So we call this is a chiplet die bank. What if we prepare this die bank in advance with all the different choices? When there is an application, we need a particular IoT device, then we just select from each category, like the next view graph, please. Yeah. And with this selection, we're connecting them together using our advanced package platform. And we call this, instead of integrated circuit, we call this integrated chips, because we integrate these chips on one platform. By doing that, we can address the very scattered market demand for IoT. Also, this gives you the performance-wise very similar to one single chip. It's very important. So with that, this is a technology base. And the business model will be, we call it system foundry. Like my boss, Mr. Liu just said, Honghai used to be, we also serve a system company, but we provide the manufacturing service. So, however, we are transformed into the solution provider instead of manufacturing service. And the difference is we give more technical content. In this model, what Honghai will provide this chiplet die bank, as I just said. And then we also provide the advanced package platform, system partitioning, system design, even the operating software. So when we have a customer come over, this customer have a very good idea for a special IoT product. Right now, this company, they have to hire a group of people to design IC. Maybe hire 50, 100 people design IC. And take 1 year to design and take 6 months to send it to the wafer foundry to get the chip. So when they introduce the product, it will be 2 years later. With this business model, they can come to Honghai. We can put, with this die bank, we can pick up, and the turnaround time for advanced package, because it's very short process, so much shorter than wafers. You can get a wafer back in less than 1 month. So this entire process will be shrunk from 2 years to 6 months. So the customer will, if you have a good concept for the good product, you can, if you come to work with Honghai, you can save your manpower, save your capital investment, most importantly, time to market. If you look from the other hand, it's this IoT product, the 1,000 different products. If each company doing their own job, a lot of duplicating effort. So in this case, Honghai will do that for them, and we can really save a lot of manpower in this case. So this is a basic business model for system foundry. Of course, it takes some time to, and Honghai will not be able to do everything ourselves. We have to build an ecosystem with many partners, like in the wafer foundry, design house, EDA vendors, all these work together with agreed standard for IOs. So this is the first part of our long-term strategy. We propose a new business model, system foundry. And next, I'd like to share with you our silicon deployment in electric vehicles specifically. Honghai has been a very successful company with many different strengths, but semiconductor has not been one of them. That's why these belong to these 3+3 initiatives. But when I look at the Honghai's semiconductor involvement, I found that actually we are one of very, very few companies have involvement in entire semiconductor supply chain, from materials to wafer fab operation to semiconductor equipment, semiconductor wafer fab, and to package, to design service, product design, to system implementation. But we have a little bit everything. Why that's the case? Because Foxconn has been doing a very, very good job in the supply chain management. And we all remember 2 years ago, we have a big shortage in IC chips. There are many cars cannot be delivered because couldn't get a good IC. This is a supply chain issue. When we had a little bit involved in everything, allowed us to get a first-hand information, something happening in this area, and we can react faster. So the supply chain management is very important to Foxconn. With the same idea, when our silicon deployment in EV is, the semiconductor market in electric vehicle approximately about $2,000 a car. And this, we divide it into power device, analog IC, and a digital IC. Digital IC takes about half of that, about $1,000, and power and small analog IC about 500. Why we need a power device become such important? Because it's the battery operated, and it's a DC, and then the motor is an AC motor. So we just convert the power. Also, when you operate a higher voltage, you have a better efficiency. So it go up to 1,200 volts. And 1,200 volts is beyond what silicon can handle. So we began to use some new materials such as silicon carbide, gallium nitride. So we, in this case, this power device case, Hon Hai's deployment strategy is we will do everything. We began from grow the substrate to epi to wafer manufacturing, device design, circuit design, package, and deployment. We will offer everything. That allows us to optimize the entire supply chain and also to make sure that we can secure this supply chain. For the analog IC, those analog IC is, in general, is relatively smaller. Actually, in the company, we call small IC. So in many applications, customer would rather we package a few of them together as a module. So the strategy here is that we are a joint venture with Guoji, and we design some IC. We offer both components and module for the convenience of our customers. Then the digital IC is we call big IC. Relatively speaking, Hon Hai has little involvement in the past in this big IC. So what we will do, we will partner with many. In one way, we have a joint venture with customers to form the design house. Another way, we partner with many different partners to make sure our supply chain management is well covered. So this concludes my presentation. Thank you so much.
Thank you. Let's give another round of applause to Chief Strategy Officer. Ladies and gentlemen, let's give it up for Mr. Jun Seki, Chief Strategy Officer for EV, and our special guest, Dr. Holger Klein. Let's give them a round of applause.
So, Chairman Du and 各位来宾，大家好。 Let me introduce our very important partner and friend and CEO of fastest growth automotive company, German giant ZF, Dr. Klein Holger.
大家好。
First, look at these pretty pictures. Nice smile. There was July 24th. I went to Friedrichshafen, ZF headquarters located in Germany. It's a south end of Germany. And then it's a nice place. In the front, there are big lake, and over the lake is Switzerland. It's almost very similar to Hakone in Japan. So hard to believe, very large company located headquarters, but it's a nice place. And then we had signed for joint venture. ZF has 8 business divisions. One of the division is chassis. And then under chassis division, there are 4 groups. And then after further discussions, we agreed to have a manufacturing group out, and then we made a joint venture. Because we are so sure we have a very big synergy, we have a potentially big growth from this new JVs. Dr. Green?
Thank you very much, and I can't wait to start operating with you as a partner together. We are just waiting the process of legal acceptance. But once we have that, we can start, and I think it's very, very complementary because we have here the largest technology provider in the world, with us the 3rd largest automotive supplier in the world. And we are very much looking forward to taking the synergies and bringing the business to new frontiers.
Thank you. By the way, we provide the technology, but we provide solutions. Okay, so Dr. Crane, why don't you introduce ZF briefly for our guest?
Yeah, my pleasure. Yeah, I'm talking about an automotive supplier in the midst of a transformation. And what we do is we are trying to shape next generation mobility. So where do we come from? We have a rich heritage of about more than 100 years, and we got started as a gear manufacturer for Count Zeppelin building airships. As you can tell, from there to becoming a tech company, 3rd largest automotive supplier, you need to reinvent yourself a couple of times. Today, we are a system supplier to the auto industry along all segments you see here on the chart, from e-bikes to pass car to heavy commercial vehicles, and we are even in the wind generating windmill business. So broad portfolio, all then connected by those technologies: automated driving, vehicle motion control, integrated safety, and e-mobility. That's what the F is about.
Thank you very much. Can you come a little closer this side? Thank you. So, very fast growth, because you are capturing all changes. I would like to ask you, what else, major changes coming for next 5 years, 10 years?
Yeah, let me give you some examples, perhaps talking about the change of the F. And basically, we all talk about 3 transformations we are going through in the auto industry. The first is battery electric. The second is software-defined car. The third is autonomous. And if we go back one slide. One more. It all starts for us with battery electric. We got into this in 2016. Yeah, not even 10 years ago. And we came from transmissions. So now we have an order book of 30 billion euros in electric drive lines, and we are very much at the forefront of innovation. So what does that mean? For example, we are very much in rare earth-free, magnet-free e-engines. That's what we introduced this year at the IAA Mobility in Munich, which make it very compact and very sustainable with a CO2 footprint. So we are as well in the inverter business, driving the energy efficiency of the system, and this is then very much around chip silicon carbide. There we partner with Wolfspeed, and you can tell we are very much in this ecosystem thought. So if we talk about software-defined car, we talk immediately about the brain of the car, high-performance computers. And it's very nice to see Jensen here on stage. In 2017, we partnered with Jensen to bring the first high-performance computer into the car, us bringing the expertise on automated graded components and bringing that into our Pro AIs. This is now the latest model. We presented 1,500 tera-ops and 12 million of those units sold. All that started 8 years ago. Yeah, so fast change, as you can tell, and always with strong partners.
Wow. Many people knows when you hear ZF, image is gear, isn't it? You know, it was more than almost a century ago. Yeah? Started with large skyship gear. That was the origin of the ZF, I believe. But with those 5 years, you said 2016, it's almost 7 years, you transformed this company to more like electric companies. Wow, that's a speed. So many changes. I think you need speed for grasp those, but what is the biggest challenge for next 5 years?
So I think the speed of the industry is even increasing. Yeah, and we are pretty large for our industry, if you want, third largest automotive supplier. But the industry is enhanced, yeah, with high-tech players like yourself. Yeah, so I think that's a big, big opportunity, and we see speed is key, yeah, because we come from product development cycles of 5 years plus 7 years even. Now we see what you did with your car. It took you 2 to 3 years to bring the new car on the road. This is amazing. So speed is one. Second is scalability, modules. Yeah, so we need to bring down cost in this industry. The more high tech we bring into it, the more expensive it gets, and that's why you need to scale. That's why we said partner with partners who know what they are doing in their respective field of expertise, bring forces together, avoid waste in development, and scale it. And I think more and more of this is to be seen. The industry is getting more and more into ecosystems, and you yourself presented today another step into this, and we are very proud to partner with Foxconn with you here in that regard.
Thank you. I fully agree. I'm from automotive OEM background. Usually, very beginning of concept to launch in the market takes 5 to 6 years. That was okay up to like 10, 15 years ago. Once we predicted what's happening 5 years later, maybe 80% accurate. Nowadays, if you predict 5 years later, only 20% accurate, 80% wrong. So only the way to increase this accuracy is make a lead time shorter. That is speed, isn't it? So in order to speed, as Dr. Crane said, modularizations, platformization is very important because make fixed part larger, application parts smaller. That is make a lead time shorter, cost cheaper, investment cheaper. I think that is very key.
Absolutely, and you see how we are connecting then to the non-automotive world. Yeah, if talk about battery electric vehicle, we talk about bi-directional charging, we talk about smart cities. So it's all interconnected and moving fast.
Yeah. So therefore, we have a tremendous opportunity to work together.
We do. We do.
Thank you very much.
Thank you.
Thank you very much. Thank you very much.
Thank you, Dr. Holger Klein, for capturing the audiences so well. Thank you.
So, people, maybe it's a little boring, but let me continue another 10 minutes for EV strategies. I think everyone knows me, so let me skip this. Let me start with EV market. I pick up two major points. First, EV is coming, but mainly those because of regulation change, because of incentives. People still hate EV. This is the reality. Because expensive, because inconvenient, and because unprofitable for makers. Year by year, these are gradually improving. Evidently, it's gradually increasing, but this is still remain. This is the demographic distribution in this planet. So triangle is total population, 8 billion. And the vertical axis is incomes. So low end is very poor, top is extremely rich. Before we talk about EVs, new car vehicle sales threshold is this yellow line. So about 22 billion people can reach new car. 6 billion people never reach new car. This is car sales. Meanwhile, this is EV. EV is very, very expensive because very large batteries and over connectivity and over autonomous drivers. No. Under red line between yellows, many people don't need these or need more softer ones. So real electric vehicle escalation only happens to drag this red line down. Next thing about market is regulations and countries' objectives. These are EV growth for China upper side and lower Europe side. So China, by July this year, already reaching 31%. 1 out of 3 new car already electrified. This, of course, removed hybrid. This is a pure EV and plug-in hybrid. Europe already above 20%. Last year, total EV sales in this planet was about 10 million. China sold 5.5 million, and Europe sold 2.5 million. So 8 million coming from those two markets. Other half, only 2 million. This is speed difference. Why? I told you 3 pays, expensive, inconvenient, unprofitable. Those two countries different? Say, what's the difference? This is a buyer's motivations. Vertical axis is buyer's motivation, very high is high motivated. EV is very low, unfortunately, because expensive, inconvenient, and many market countries supporting subsidy for buyers. So after subsidy, it's become a little higher, but still low. This is what China and Europe doing. Middle high, very high bar is a normal motivation for ICE vehicle purchase. And then China and Europe attacking this motivation lower. Like China, number plate restrictions. You know, if you need an ICE vehicle, you have to wait 1 year. If you need an EV, you can get it tomorrow without any additional money. And in Europe, emission regulation becomes severer and severer. You know, second, resale value from ICE car getting lower and lower. So by this successfully made, and then evidently after regulations, ICE motivation and EV motivation become very close. That's why those two markets, EV increasing very fast. Question is, if China, Europe doing this for pure CO2, of course, CO2 is very important, but they have other own object. This is just sample of China. Red portion is China local OEM share, like BYDs, Geelys, Guangzhou Motors, Shanghai Motors. Blue portion is global players, Volkswagen, Toyotas, GMs. 10 years ago, it was 38 to 62. This is not simply 38 to 62, because local brand had like a 30% discount, but still 38%. And that flipped last year, 52 to 48. And by July this year, it's 59 to 41, about 60%. This is what China government wanted to see. Yeah? And this has happened because electrified vehicle contribution is very different between global player and China player. China player is very fast and growing, and that made the share balance very different. Okay? Then, next question is, who is next? Who coming next? We have a guest from India. I really believe India is coming. Because India is aggressively investing renewable energies. Over India, I think it's very close to 40% against the total energy usage. And then I think India is targeting over 50%. And then meanwhile, India started to provide the regulation change. It was May, like Delhi, Bangalore, Mumbai, those big cities provided the ban to use ICE two-wheel for taxi. So if you continue taxi business by two-wheel, you have to swap to EV. This will expand to many other states, and also probably this will expand to three-wheel, four-wheel taxis. But this really makes sense. You know, taxi usually drive 400 kilometers per day. Standard vehicle drive only 20 to 30 kilometers. If you want to contribute to CO2 reductions, long distance drive electrification is more effective. So I really feel very smart idea for this one. And then, as I said, always government has like a hidden object. This is my personal guess, but I think Indian government want to have less oil dependencies. India has a huge coal still. Coal plus renewable energy already, in the future, will extend real usage. So that time, they will realize less oil dependencies. So I really believe China, India coming next, start from taxi business. I have many other data, but because time limited, this is last for Japan. I'm Japanese. I think we have Japanese guests somewhere, but I'm very embarrassed. No movement, no policy change. I think Japan, very smart countries, so they know if you attack ice like this way, EV is coming, but they don't do that. Maybe somebody blocking that. Meanwhile, Nissan Sakura, that's a smart, very compact car, only 20 kilowatt batteries. So autonomy driving range is less 200 kilometers. Real range is about 100 kilometers. But many people believe that is enough for me. I only go to cities. So those cars flying without regulation change, particularly rural areas. Because in Japan, gas station is reducing and reducing and reducing. So people need less oil dependencies because gas station is disappearing. So in Japan, it's not regulation change, but small car is coming. So those two major market trends. I have many other market trends, but based on this, I explained to you top-notch, very expensive car. This is exist. This is reality, fact. So of course we fight, we compete in this cycle too by CDMS. CDMS, we have two types of CDMS. One, as like smartphones, computing, customers' drawings, we do contracted manufacturing. We deliver cost, target, and qualities. And meanwhile, many of our new customers don't have EVs. So for those people, we offer our car. Later you will see. Yeah? Actually, today we have a Model C in there. So we do this. And then, as India's case, Japan case, small car and low-cost car is required. So we attack bottom areas too. Okay? And then we believe if we go modularization and then platformizations, more strong collaboration with our partners, I can drag this yellow line down. And also, we are working with Google's, and this is model of 4-wheel, but 2-wheel also, under this yellow line, it's work. With those two areas, this is common concept, but we do all of those